This lesson is part 2. So this is part 2 of our lesson dealing with finding the least common multiple of 2 or more terms. So it's very important that you look at the first part of this lesson. So this would be part 1. So remember, in part 1, that's where we found the least common multiple of just numbers, just whole numbers. And so remember, we did it 2 ways. We talked about in terms of actually listing the multiples of those numbers and then finding the least. And we also talked about it in terms of the prime factorization, using prime factorization. Okay, so it's very important that when you found the least common multiple, you talked about it or you understood it in both ways. Majority of our time, though, was spent on prime factorization because that's usually what students will fall back on, is just using prime factorization when these numbers become too big to deal with it mentally. Okay, so for example, so number 1, let's suppose you want to find the find the least common multiple. So find the least common multiple, and so let's suppose number 1. We want to find the least common multiple of, let's say, 9x squared y and 12, let's say, x to the 4th power. Okay, so we want to find the least common multiple. All right, so whenever you're dealing with variables, and see, they all have exponents. This is exponent 2, this is exponent 1, this is exponent 4. It is important. It is very important that you understood how to find the least common multiple, using prime factorization. Okay, so let's go back and talk about, these are written as exponents. So 3 squared, 2 squared times 3. So remember, the least common multiple, when we talked about this, the least common multiple must include every factor you see. Okay, so I saw a factor of 3 and I saw a factor of 3. Now, remember, it's every factor you see. So it doesn't mean they have to be in both. You just have to see that factor either here, or in both. Does not matter. Okay? So let's start with 2. So I see some factors of 2. I don't see any here. I still must use them. Okay? And the question is, how many do I need? Remember, the least common multiple means that your answer is going to be greater than or equal to the larger number you see. So remember, I use the word greater, so you got to use the one with the greatest exponent, with the largest exponent. So I had 0 here, 0 factors of 2. I had 2 factors of 2. I got to use 2 of them. Let's talk about 3. It just so happened that there was factors of 3 in both. Did not have to be. I have 1 factor of 3 here. I have 2 factors of 3 here. I must use the greatest possibility. So I got to use 2 of them. Okay? So that's how you found the least common multiple in terms of exponents. So if I go back to here now, so let's talk about x squared y and x to the 4th. Let's talk about that for a moment. So the least common multiple of those, okay? So the least common multiple of those is, so let's talk about that. So it must include every factor you see. So I see a factor of x, I got to use it. The question is, how many do I need? How many factors of x are in here? 2. How many factors of x are here? 4. How many do you need? 4. Okay, so remember, the least common multiple means that these 2 terms must divide into this evenly. Okay, so if I have 2 here and I have 4 here, I need 4 here in order for this to divide into it evenly. Okay, the next factor you see is a y. I got to use it. I have to use it because remember, this has divided into evenly, so that means that this must include a y. So how many factors of y do you see here? 1. How many do you see here? 0. How many do you need? 1. So that's the least common multiple of your x squared y and your x to the 4th. Now let's talk about the least common multiple of 9 and 12. So mentally, I want you to see this. Mentally, you can probably figure this out without doing something like this. Because think, remember the least common multiple, must be, in terms of 9 and 12, must be greater than or equal to 12, right? So let's talk about the multiples of 12. 12 times 1 is 12. Does 9 go into 12 evenly? Nope. The next multiple of 12 is 24. Does 9 go into 24 evenly? Nope. The next multiple of 12 is 12 times 3 is 36. Does 9 go into 36 evenly? Yes. So the least common multiple of 9 and 12, so the least common multiple of 9 and 12 is 36. So the answer, so here's the way you're going to think about this. So you look at your coefficients first. So the smallest number that 9 and 12 go into evenly is 36. Now we're going to do the variables. Let's put it in alphabetical order. So I need an x. Question is, how many do I need? Based on our discussion, I have 2 factors here, 4 factors here. I need 4. For y's, I have 1 factor here, 0 here. I need 1. So there's your answer. Okay. Number 2. So number 2, we have 15z to the 10th, and the other term is 9z to the 6th. Okay, so at this point, you're going to notice that the variables are the easiest to deal with. It's the coefficients that are harder. So let's think about the least common multiple of 9 and 15. So if you want to think about multiples, let's go ahead and do that. So I'm going to remember the least common multiple must be greater than or equal to 15. So let's talk about the multiples of 15. The multiples of 15 are 15 times 1 is 15. Does 9 go into 15 evenly? No. The next multiple of 15 is 15 times 2, which is 30. Does 9 go into 30 evenly? No. The next multiple, use your calculator if you need to, 15 times 3 is 45. Does 9 go into 45 evenly? So remember, all you got to do is check. So let's go back to 15. Does 9 go into 15 evenly? Well, 15 times 9 is this. You get a remainder, right? Other than 0. So the answer is no. You don't get a whole number. So remember, the 15 is divisible by a number if this is a whole number. And it's not. It's a decimal. 30 divided by 9 is a decimal. So that means that 9 does not go into 30 evenly. 45 divided by 9 is a whole number. So remember, that means that 9 divides into 45 evenly. So that means that if I were to look at that in terms of division, 9 times 5 is 45 with remainder 0. Okay? So notice it was easy just to use my calculator and think about multiples to get the answer. But I want to go back and talk about the prime factorization real quick. So remember, sometimes it's easy to think about this in terms of multiples. Sometimes it's easy to look at the prime factorization. So for 9, remember the prime factorization is 3 times 3? Okay? 15, remember that's 3 times 5. So remember, prime factorization is where you write your composite number as a product of prime numbers. And so the least common multiple must include every factor you see. I see a factor of 3. Question is, how many do I need? Well, I have 2 factors here, 1 factor here. So you got to use the greatest number because you need 3 times 3 to go into this. So you need 2 of them. And then I see a factor of 5, so I must include a factor of 5. I have 0 here, 1 here, so I just need 1. So your least common multiple is 3 times 3 is 9, and 9 times 5 is 45, which is what we said it was. Okay? So the least common multiple is 45. So the answer will be 45. Now let's look at the variables. How many, remember, I just see a z, right? So I just need some factors of z. It could be 1 or it could be more than 1, depending on what I have. How many factors of z do you have here? 10. How many do you have here? 6. So those 2 terms goes into this, so the least common multiple equals. So if those 2 terms goes into the least common multiple, then z to the 6th must go into this evenly, and z to the 10th must go into that evenly. So I need the one with the largest exponent, 10. There's your answer. So see, if you understood that previous lesson that dealt with just finding the least common multiple of numbers with the idea of prime factorization, then this becomes a lot easier to deal with. Okay, let's look at number 3. Number 3, let's suppose you had 10x to the third, 40x squared y, and then 50y cubed. So the least common multiple of the variables, that's easy, right? So I'm going to write it out real quick. So least common multiple, let's talk about the variables. I need x's and y's, so because you see both of them. So x and y. Question is, how many factors of x do I need? Well, how many do you have here? 3. How many do you have here for x? 2. And I have 0 here. So remember, your least common multiple, all those factors of x must divide into this evenly. So I need the one with the largest exponent. So I need 3. Let's look at y. How many factors of y do you have in here? 0. You don't see any y, so you have 0. How many factors of y you have here? 1. How many you have here? 3. How many do you need? 3. Because all of these all these variables have to divide into this evenly. So in order for these y's to divide into this evenly, the largest one has to go into it as well. Okay? Now let's talk about the coefficients. The least common multiple of 10, 40, and 50. So the least common multiple of 10, 40, and 50 means this. What's the smallest number, what's the smallest number that 10, 40, and 50 go into evenly? So if you want to use your calculator, here's the way you would have to do this, though. You got to start with the largest you see, because remember, the least common multiple must be greater than or equal to 50. So let's look at the multiples of 50. Multiples of 50. And then we'll see if the other two goes into those evenly. So the multiples of 50 are 50. Now, 10 goes into 50, but what's the problem? 40 doesn't go into 50 evenly, because 50 divided by 40 is not a whole number. The next multiple of 50 is 100. 10 goes in 100 evenly, because 10 times 10 is 100, but 40 doesn't go in 100 evenly, because 100 divided by 40 is this decimal. The next multiple of 50, 50 times 3 is 150. 10 goes into 150 evenly, but 40, does 40 go into 150 evenly? Nope, you get a decimal. The next multiple of 50 is 50 times 4. So 50 times 1, 50 times 2, 50 times 3, 50 times 4 is 200. So 10 goes into 200 because 10 times 20 is 200. So you could have just done this, 200 divided by 10. See, that's a whole number. But does 40 go into 200 evenly? 200 divided by 40? The answer is yes. So you found it. So there's the least common multiple. So the least common multiple of 10, 40, and 50 is 200. So this is going to be 200 x to the third, y to the third. Now, I want to go back and use the prime factorization real quick, just to show you how to find it using this. So remember, I did this using the multiples of 50. I used the largest possible. Remember, the least common multiple has to be greater than equal to 50, so that's why I just did the multiples of 50 and just found the one that these two go into evenly. Okay? So let's look at the prime factorization. Do y'all agree that 10 is 2 times 5? Okay? And now let's get 40. 40, I get 4 times 10. 4 is 2 times 2, so those are prime numbers. 10 is 2 times 5, and those are prime numbers. So 40, y'all agree, is 2 to the third times 5. Okay, and let's look at 50. 50 is easy. That's just 2 times 25, and 25 is 5 times 5. So y'all agree that that's this? Okay, so once you find the prime factorization, the least common multiple must include every factor you see. So I see a factor of 2. The question is, how many do I need? I have 1 factor 2 here, 3 here, 1 here. I need the one with the largest exponent because least common multiple, remember, each of those has divided into this. So I need 2 to the third divided into this, so I need 2 to the third. Times, I see a factor of 5. So I'm going to use a 5. Now remember, it doesn't have to be in all of them, just has to be in at least one of them. So I have 1 factor here, 1 factor here, 2 here. So I need how many? 2. And so therefore I get 2 to the third, which is 8. And then 5 squared, which is 25. And then 8 times 25 is 200. And so that's how we can use the prime factorization to help you find the least common multiple. Okay? All right, so again, remember the first thing you're going to do, the part that's easiest first is to find the least common multiple of your variables. That's the easiest first. Then to find the least common multiple of your coefficients, you can do it one of two ways. You can determine that using the multiples of the larger and see if the others will go into it evenly. Or I can do a prime factorization and then go from there. All right. So if you have time, though, it's always a good idea to do it both ways. Do it both ways if you have time. All right, so that's number 3. Let's look at number 4. Number 4, we have 5 times x minus 3, comma, and then 13 times x minus 3. Okay, so there are times, now when we start talking about least common denominator, the first thing you have to do is factor your denominator. So remember when you factored, you had situations like this where one of your factors was a binomial. All right, so don't confuse that with number 3. It's the same idea. It's the same idea. It's just that these were monomial factors. Here you have a monomial times a binomial. So don't let that confuse you. It's still an easy thing to deal with. So let's go ahead and find the least common multiple of your coefficients, 5 and 13. So the least common multiple will equal. So notice that both of those are prime, right? 5's a prime number. So the prime factorization of 5 is just 5. 13 is a prime number, so that's just 13. And so the least common multiple must include every factor you see. So 5 times 13, that's your least common multiple. So 5 times 13 is 65. Okay? Then let's look at the other factors. I see a factor of x minus 3, right? So I must use it. Question is, how many do I need? Well, how many factors of x minus 3 do you have here? 1. How many factors of x minus 3 do you have here? 1. How many do you need? Just 1. So there's your answer. The least common multiple of these two is this, because 5 goes into 65, and then 13 goes into 65, and 65 is the smallest. X minus 3 goes into this, x minus 3 goes into this. Okay? All right, number 5. Number 5, we have 24 times x plus 4, comma, and then 36 times x plus 4 cubed. Okay? So let's just go ahead and start talking about the coefficients. So the least common multiple of 24 and 36. 24 and 36. So again, if you want to think about this in terms of the common multiples of 36, you can. Okay, here's what you would do. So you're going to say 36 times 1 is 36, right? The question is, does 24 go to 36 evenly? Well, think about it. Is that a whole number? No. The next multiple of 36, 36 times 2, right, is 72. Write it down. And then ask yourself, will 24 go to 72? So say divide by 24, you get 3, and yes, so there, you found it right away, right? You found it right away. So the least common multiple of 24 and 36 is 72. So the least common multiple will equal 72, and then let's look at the at the factors. I see a factor of x plus 4, I must use it. All right, the question is, how many do I need? How many factors of x plus 4 you have here? 1. How many factors of x plus 4 you have here? 3. In order for those two to go into the least common multiple, that means that x plus 4 to the third power must go into this. So I need 3 of them. So there's your answer. Now let's go back to this and let's look at the prime factorization, because I need for you to understand both ways. Prime factorization. So 24, let's do the prime factorization of 24. So 24 is 4 times 6. 4 is 2 times 2. Those are primes. 6 is 2 times 3. Those are prime numbers. So therefore, the prime factorization for 24 is 2 to the third times 3. Agree? Now for 36, the prime factorization of 36 is 6 times 6. Those are composite numbers, so I got to go further. 6 is 2 times 3. Those are primes. 6 is 2 times 3. Those are primes. And so I get 2 to the second times 3 to the second. 2 factors of 2, 2 factors of 3. And so the least common multiple must include every factor you see. I see a factor of 2 and I see a factor of 3. Question is, how many do I need? How many factors of 2 are in here? 3. How many factors of 2 in here? 2. How many do I need? 3, because 8 must go into this, so I need an 8 here. Because 2 to the third is 8, right? And so this has to be at least an 8. How many factors of 3 do you see here? 1. How many factors of 3 do you see here? 2. So how many do I need? 2. Think about this. This is 9, right? So 9 must go into this. So I need a 9 here. Okay? And so therefore you get 2 to the third, which is 8, 3 to the second, which is 9, and 9 times 8 is 72, and that's what we said it was. All right, so that was number 5. Number 6, let's number 6. So see, it's not that bad if you go back to that previous lesson. So number 6, we have 4x squared, comma, 3x squared y cubed, comma, 28xy to the fourth. All right, so I have 3 terms. Those are all monomial factors. You see, in number 5, if you look at those 2 terms, this was a monomial, this is a binomial, this is a monomial, this is a binomial. All right, so here those are all monomial factors. So let's look at the coefficients first, 4, 3, and 28. So let's find the least common multiple of 4, 3, and 28. So again, if you want to look at this in terms of common multiples of 28 and see which one 4 and 3 goes into evenly, then that will be your least one. So the common multiples of 28. 28 times 1 is 28. The question is, does 4 go into 28? So remember, all 3 have to go into this. So we know 28 goes into it because that's a multiple of 28. But let's check the others. 28 divided by 4 is 7. 28 divided by 4 is 7, which you knew it was right away, right? Because 4 times 7 is 28. But does 3 go into 28? 28 divided by 3 is a decimal, so no. So we got to keep on going. 28 times 2, the next multiple of 28 is 56. So let's see if 56 is divisible by 4. So I want you to notice this. So if 4 is divisible into 28, then 4 has to be divisible to 56 because in 56, 28 times 2, the only issue is this 3. We got to just check the 3. So 4 goes into 28. So whatever multiple of 28 we have here, 4 will go into it. It's just this 3 that's going to be the issue. But many students don't think about it like that, so they just keep checking all of them. That's fine. So in other words, if you want to verify that 4 goes into 56 evenly, go ahead and do it. But what I was saying was that 4 goes into 28. So whenever you list your factors of 28, 4 will go into all of them. Now let's look at 3. That's 56. So does 3 go into 56 evenly? 56 divided by 3, answer is no. So I must keep on going. 28 times 3 is 84. Okay? So I know that 4 will go into 84 because 4 goes into 28. But let's check 3. 84 divided by 3. Yep, we got it. Because 3 times 28 is 84. So this is it, 84. 84 is our answer. So that's how you can find the least common multiple, by just looking at the multiples of the largest number you see and then just checking to see if both of these goes into that evenly. So therefore, the least common multiple is going to equal 84, and the rest is easy. I must have an x and I must have a y. Question is, how many do I need? How many factors of x do you have here? 2. How many do you have here? 2. How many do you have here? 1. Remember, whatever you use, all of these have to go into this evenly, so I must use the largest amount. So 2. How many factors of y do you have in here? 0. How many do you have in here? 3. How many do you have in here? 4. So if all of these goes into this, then I must have it. I must have y to the 4th here, because I need y to the 4th to go into this. Because y to the 3rd goes into it, and then there are no y's here, so we're fine. Okay, so there's your least common multiple. Now let's go ahead and find the least common multiple here using the prime factorization. So the prime factorization of 28, let's see, that's 7 times 4, right? 7's prime, 4 is 2 times 2, and 2's are prime. So 28 will be 2 to the second power times 7. Let's look at 56. So 56 is 2 times 56 divided by 2, use your calculator, is 28. 28, I already have it, so I'm just going to list these again. So 28, let me just go do it again. So 28, remember, is 7 times 4, and 4 is 2 times 2. And so I get 2 to the third power, because there are 2 factors, 1, 2, 3. There are 2 factors of 2, and then 1 factor of 7. And then, oops, I'm sorry, I did not mean 56. Excuse me, it's my mistake. It's these I got to use. So I made the mistake. Okay, so let's do this again. So I'm trying to find the prime factorization of these. So 4, remember, is 2 times 2, right? It was my mistake. I apologize. 3 is a prime number, so I'm just going to put it 3. And then 28 we found was 2 to the second power times 7. Okay, now the least common multiple, I must include every factor I see. So I see a 2, right, in multiple places. And I see a 3 just here. I got to use it. And I see a 7 just in this one. Question is, how many do I need? How many factors of 2's are in here? There are 2 of them. How many are in here? 0. How many in here? 2. How many do I need? 2. How many factors of 3 are in here? 0. How many are in here? 1. How many are in here? 0. How many do you need? 1. How many factors of 7 are in 4? 0. How many factors of 7 are in 3? 0. How many factors of 7 are in 28? 1. How many do I need? 1. And so therefore the answer is 4 times 3 times 7. So that's 12 times 7, which is 84. Okay? All right. So you can get it either by doing it this way or by looking at your prime factorization of 4, 3, and 28 and then going from there. All right, so it's not that bad. Fairly easy to deal with. Okay, number 7. Number 7, you have x, comma, x plus 5, comma, x minus 3. So it is possible when we talk about adding and subtracting fractions where you could have these as your denominators. So notice, though, that here I have a monomial factor. Here, this is a binomial. Can't do anything else to this. Cannot factor that. And then I cannot factor that. So your least common multiple, remember, your least common multiple must include every factor you see. I see an x. I see an x plus 5. And I see an x minus 3. So remember, your least common multiple is a product. So that's why you see I'm having multiplication here. So how many factors of x do you have here? 1. How many factors of x do you have here? 0. Don't say this because that's not a factor. X plus 5 is a factor. How many factors of x are in here? 0. So how many do you need? Just 1. Let's go to the next one, x plus 5. How many factors of x plus 5 are in here? 0. Here, 1. Here, 0. I need 1. How many factors of x minus 3 are in here? 0. 0. 1. I need 1. So there's your answer. At least common multiple. So when we talk about in the next lesson, or the 2 lessons from now, when we talk about the least common multiple, then you are going to see situations where it's just a product of factors and just leave it as a product of factors. Number 8, let's suppose we had y squared minus 16, comma, y squared minus y minus 12. Okay, now listen carefully. So in finding the least common multiple, you need to make sure that these polynomials, see these are polynomials, that these polynomials are factored, okay? So when I factor this, that's going to be y minus 4 times y plus 4. When I factor this, that's going to be y minus 4 times y plus 3, okay? So first thing you got to do is make sure that when you have polynomials, you got to make sure they're factored. Now let's talk about the least common multiple. The least common multiple is a product of factors. All right, you got to look at each factor and see how many you need. So I need a y minus 4 because I see one here. I need a y plus 4 because I see 1 here. I need a y minus 4. I already have it. I see a y plus 3. I don't have it, so I need 1. So the question is, how many of each do you need? How many of each do you need? How many factors of y minus 4 are in here? 1. How many factors of y minus 4 are in here? 1. How many do you need? 1. Let's go to y plus 4. How many factors of y plus 4 are in this one? 1. How many are in this one? 0. How many do you need? 1. How many factors of y plus 3 are in here? 0. How many are in here? 1. How many do I need? 1. So your answer is just this without, and remember, these are exponents 1, so just rewrite it without the 1. So it's y minus 4 times y plus 4 times y plus 3. So there's your answer. Okay, number 9. Number 9, we have 15 w to the 8th, comma, 27 w to the 5th, comma, 45 w to the 7th, comma, w to the 9th. Okay? And so let's now notice this time I have 2 terms. Those are all monomial factors. The monomial factors are the easiest to deal with. See here, those were polynomials, so I had to factor first before finding the least common multiple. Here, those are just monomial factors. So let's look at the coefficients, 15, 27, 45, and 1, right? 45 and 1. And so the least common multiple of 15, 27, 45, and 1, we got to figure that out. Okay? So if you want to talk about, least common multiples of 15, 27, 45, and 1. So you can look at this in terms of looking at the largest first and look at the multiples. So the multiples of 45 are 45 times 1 is 45. So let's see if 15 goes into 45. 45 divided by 15, yes it does. Let's see if 27 goes into 45. 45 divided by 27, nope, it does not. Now 1 goes into everything, so we can go to the next factor of 45. Next multiple of 45. So 45 times 2 is 90, right? So now I want you to remember what we talked about earlier. 15 goes into 45, so that means that 15 is going to go into the multiples of 45. So I'm just going to look at 27. Does 27 go into 90 evenly? So 90 divided by 27. Nope, it does not. So then I got to go to the next multiple of 45. 45 times 3 is 135. And so I know that 15 goes into 45, so that means that 15 must go into this. And you can check it, 135 divided by 15, so you get a whole number. But I need to check the 27. 135 divided by 27 is a whole number. So I found it, 135. And notice that 1 goes into all of these. So 135. So the least common multiple of my coefficients is 135. Now the variable is easy. All I see are w's, so I know I'm going to need some w's here. Question is how many? How many factors of w do you have here? 8. How many do you have here? 5. How many do you have here? 7. How many do you have here? 9. How many do you need? You need the one of the largest, 9. Because remember, all of these has to go into this evenly. So in order for all of these to go into this evenly, then the largest exponent has to be part of this. Okay, so there's your answer. Now let's go back and look at this in terms of prime factorization, just to remind you how to deal with this. So the prime factorization of 15 is 3 times 5. That one was easy. The prime factorization of 27 is 3 times 9, and 9 is 3 times 3. So that's 3 to the third. The prime factorization of 45, let's do it this way. 45, remember it's 5 times 9, right? 5 is prime. 9 is 3 times 3. And those are primes, so that's going to be 3 squared times 5. Okay? So therefore, the least common multiple must include every factor you see. So I see 3's and 5's. Question is, how many 3's do I need? How many factors are 3 in here? 1. How many in here? 3. How many in here? 2. How many do you need? 3. How many factors of 5 are in 15? Just 1. How many factors of 5 are in 27? 0. How many factors are in 45? Just 1. So how many do you need? 1. So therefore the answer is 3 to the third, which is 27. Although you could, if you don't, you should know that. But if for some reason you just use your calculator, you would say 3 raised to the third times 5 equal 135. And that's what we said. Okay? All right, so that was number 9. Let's look at number 10. Number 10, we have, let's say, x squared plus 5x, comma, and then x cubed minus 4x squared plus 4x. All right. So based on what we talked about a while ago, see you have polynomials. What must you do first before you find the least common multiple? Well, you got to factor first. Okay. So let's factor that first term, that first polynomial. So I can factor out an x, and I get x times x plus 5. Okay. So your factors are x and x plus 5. The next one, first of all, I got to factor out an x, right? So I get x times x squared plus, minus 4x plus 4. And then I can factor this further. So it's going to be x times x minus 2 times x minus 2. Okay? All right. Now, let's go ahead and find the least common multiple. So the least common multiple must include every factor you see. Okay? So I see an x, I got to use it. I see an x plus 5, I got to use it. I see an x, I already have it. I see an x minus 2, I have to use it. Now the question is, how many of each do you need? How many factors of each do you need? How many factors of x do you see here? Just one. How many factors of x do you see here? Just one. How many do I need? Just one. How many factors of x plus 5 do you have here? Just one factor of x plus 5. See, x plus 5 to the first. How many factors of x plus 5 are in here? 0. How many do you need? Just one. How many factors of x minus 2 do I have here? 0. How many factors of x minus 2 do I have here? 2 of them. How many do I need? 2. So there's your answer. Okay? Number 11. Number 11, I have x squared minus 8x plus 15, comma, x squared minus 10x plus 25. So I have these two polynomials. Now remember, whenever you're dealing with monomials, those are easy to deal with. When you're dealing with polynomials, you got to do what to those first? You got to factor. See, these are already factored. So that was easy. I couldn't factor any further. But number 8, I could. And in number 11, I could. And number 10, I could. So if I look at this one, I'm going to get, let's see, when I factor those, looks like I'm going to get x minus minus, the last sign's positive, so these have to be the same. And it's going to be 5 and 3. Over here, looks like that's going to be x minus 5 times x minus 5. Okay? All right, so your least common multiple must include every factor you see. I see an x minus 5. I got to have at least one of them. I have an x minus 3, so I know I'm going to have something in there. I have an x minus 5. I already have it listed. Okay? Don't list it again. It's already listed. But now the question is, how many do you need? The question is, remember, you want to find the least, so you got to use the least number possible. How many factors of x minus 5 do I have here? 1. How many factors of x minus 5 do I have here? 2. So remember, that means x minus 5 squared. So how many do I need? I need 2 of them. Okay, and that's going to give you your least. How many factors of x, the next one's x minus 3. How many factors of x minus 3 are in this one? Just 1. How many in here? 0. You need just 1. So there's your answer. Okay. All right, and then finally, number 12. Number 12, I have 3a minus 15, comma, a squared minus 5a. So, now remember, these are polynomials, so let's factor those. I can factor out a 3, and I get 3 times a minus 5. Here, I can factor out an a, and I get a times a minus 5. Okay? So remember, your least common multiple must include every factor you see. So remember, your factors are 3, a minus 5, a minus 5. So I see a 3, I see an a, and I see an a minus 5, right? Okay, question is, how many of each do you need? How many factors of 3 are in here? Just 1. How many factors of 3 in here? None. How many do I need? Just 1. How many factors of a are in here? 0. How many factors of a in here? Just 1. Remember, a to the first, so just 1. How many do I need? Just one. Now a minus 5. How many factors of a minus 5 are in here? Just one. Or a minus 5 to the first. Just one here. You just need just one, so there's your answer. Okay? All right, so this was part 2 of our continuation about the least common multiple. Now in part 2, that's where we started talking about variables. So some of these involve monomial factors. If it's just monomial factors, it's a little bit easier to deal with. Some involve polynomials, so where you had to factor first, and then you found your least common multiple. All right, so it's very important. It's very important you go back and you make sure that you understand all of these problems. The problems dealing with where you had to factor first and then find the LCM, and then the problems where you were just given monomial factors and then you found the LCM of those. Okay, so that's going to be the end of this lesson. So that's the lesson for part 2.